Revision on whole numbers. When we begin counting, we start counting as 1, 2, 3, 4. The counting comes naturally. So they are called natural numbers or counting numbers. When you add 0 to the collection of natural numbers, then it is called as whole numbers. So now predecessor and successor. So to find out successor, you need to add 1. So when you add 1 to 99, then you get 100. So 100 is called as the successor of 99. To get predecessor, you need to subtract 1. You get 98. So 98 is the predecessor of 99. Number line of a whole number. The number line of a whole number, it begins from 0 because 0 is the smallest whole number. Then we have 1, plus 1 is 2, plus 1 is 3, plus 1 is 4, and so on. So this is a number line for whole numbers. Let us see how to add whole numbers on number line. So first you need to draw a whole number line. So this is 0, 1, 2, 3, 4, 5, 6. So if you want to add say 2 plus 4. Okay, so first you need to find out 2. Where is 2? 2 is here. And you need to add plus 4. So plus 1 plus 2 plus 3 plus 4. So where do you reach? You reach 6. So 2 plus 4 is 6. Now let us see how to do subtraction on number line. Say for example 7 minus 2. So to do that, first let us draw a whole number line. Starts from 0, then 1, 2, 3, 4, 5, 6, 7, 8. So to find out 7 minus 2, you first need to locate 7. Minus 2, you are subtracting 2. So you will move in left side. So 1, 2. Where do you reach? 5. So you have reduced 2. So the answer is 7 minus 2 is 5. To add, you move in right direction. To subtract, you move towards left. Now multiplication. If you have to multiply 4 into 3 on number line, how will you do it? First you need to draw the number line. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 4 times 3. This is 1 times 3. This is 2 times 3. This is 3 times 3. And this is 4 times 3. So where did you finally reach? You reached 12. So 4 into 3 is 12. Properties of whole numbers. So first property here is closure property. Let us discuss addition. So whenever you add two whole numbers and you get a whole number, then we say it is closed under addition. For example, 3 plus 4 gives you 7. 6 plus 9 gives you 15. So whenever you are adding two whole numbers, you are getting a whole number. So we say whole numbers are closed under addition. Similarly, whenever you multiply two whole numbers, you get a whole number. 3 into 4 is 12, 9 into 6 is 54. So when you are multiplying two whole numbers, you are getting a whole number. So we say whole numbers are closed under multiplication. Now let us discuss subtraction. If you subtract 7 from 9, you get 2. If you subtract 8 from 7, you don't get a whole number. So, we say that whole numbers are not closed under subtraction because you are not getting a whole number here when you subtract 8 from 7. Now let us discuss division. When you divide 12 by 3, you get 4, which is a whole number. If you divide 5 by 7, you get a fraction, which is not a whole number. So we say whole numbers are not closed under division. Now division by 0. Whenever you divide any whole number by 0, it is not defined. Now moving on to commutativity of addition and multiplication. So what is commutative property? Say for example, if you add 3 plus 4, you get 7. You can add 4 plus 3, you get 7. So you can add in any order. You can add 4 to 3 or you can add 3 to 4. The result is the same. For example, if you add 6 and 7. So, what do you get? 6 plus 7, you get 13. Or you can add 7 plus 6. Here also you are getting 13. But here you are adding 7 to 6. Here you are adding 6 to 7. So, when you add, the order does not matter. You are going to get the same result. Similarly, for multiplication, 3 into 4 is 12. Here you are multiplying 3 to 4 and here you are multiplying 4 to 3. In both the cases, the answer is 12. So you can multiply in any order. Now, associativity of addition and multiplication. That means this is commutativity is for two numbers, associativity is for three numbers. For example, if I take 1 plus 2, first I will add these two numbers plus 3. So brackets has to be solved first. So 1 plus 2 is 3. 3, the result 3, we are adding to 3. So we will get 6. I can add it like this also. 1 plus 2 plus 3. So first I am going to add 2 and 3. So 2 plus 3 is 5. Plus 1 is 6. So here you can see that whether you add 1 to 2 and the result you add it to 3, it is same as you add 2 plus 3 first and the result you can add it to 1. So this is called associativity of addition. Now let us see multiplication. Instead of plus sign, now we are going to put multiplication sign. So we can multiply 1 into 2 first and then we can multiply the result with 3. So 1 into 2 is 2, into 3 is 6. In the second case, what we can do is, we can multiply first 2 into 3. What do you get? 6. The result you multiply to 1, you get 6. So both sides you get 6. So this is called associativity of multiplication for whole numbers. Now let us discuss distributivity of multiplication over addition. Means if I have to multiply 2 into 3 plus 4. So this is called distributivity of multiplication over addition. So first you multiply 2 into 3. Then here is a plus sign. So we put a plus sign. Then 2 into 4. So whatever is outside the bracket, you need to multiply with all the numbers which are there inside the brackets. So 3 into 2 is 6 and 4 into 2 is 8. So 6 plus 8 is 14. So this is called distributivity of multiplication over addition. If you have here instead of plus, say minus 1 into say 2 minus 1. Okay, so this is called distributivity of multiplication over subtraction because here it is minus sign. So we multiply 1 into 2 and here it is minus sign. So I am going to put minus. Then you multiply 1 into 1. So this is 2 minus 1. This is 1. Moving on to additive identity. Whenever you will add any number to the 0, you are going to get the same number. So 0 plus 7 is 7, 15 plus 0 is 15, 13 plus 0 is 13. So whenever you are adding any number to the 0, you are getting the same number. So 0 is called the additive identity for whole numbers. Now, multiplicative identity. Whenever you multiply any number to 1, you are going to get the same number. 15 into 1 is 15. 1 into 27 is 27. So, if you are multiplying any number to 1, you are getting the same number. So, 1 is called as the multiplicative identity for whole numbers. Patterns in whole numbers. Every number can be arranged as a line. For example, 2 you can arrange in a line like this. For example, 3 you can arrange in a line like this. 4, 5, 6 and so on. All the numbers can be arranged in a line. Some numbers can be shown also as rectangles. For example, 6. I have made 6 dots. I have arranged 6 dots in 2 rows and 3 columns. So, it is forming a rectangle. Similarly, 8, 10, 12. All these numbers you can represent as rectangles. Some numbers like 4, 9, 25, 36. These numbers can be arranged as squares. So here, can you see these 4 dots? They are forming a square. There are 9 dots here and they are forming a square. Similarly, some numbers can also be arranged as triangles. For example, 3, 6. There are 3 dots here. There are 6 dots here. Let us do some problems on whole numbers. First question is, how many whole numbers are there between 32 and 53? So before we find out the solution of this question, let us understand this by taking some small numbers. If I ask you how many numbers are there between 1 and 6, so you will try to subtract it. So you will subtract 1 from 6. What do you get? 5. So let's see, there are 5 numbers between. So 2, 3, 4 and 5. There are only 4 numbers here between 1 and 6. So if you subtract 1 from 5, you will get 4. So same way we will solve this question now. So how many numbers are there between 32 and 53? You are going to subtract 32 from 53. So you will get 21. So from this you will further subtract 1. So you get 20. So 20 numbers are there between 32 and 53. Write the predecessor of 10,000. So to find out the predecessor, what do? You subtract 1 from 10,000. So when you subtract 1 from 10,000, you keep borrowing, right? 1, 1. So 10 minus 1 is 9. Then here what do you get? 9, 9 and 9. So from 9,000, 10,000 if you subtract 1, you get 9,999. That is the predecessor of 10,000. Whenever you have to find out the predecessor, you have to subtract 1. Now let us solve by using suitable arrangement. So as you see, there are some numbers here given to you, but if you try to add it in the same order, it will be a little tricky. So let us try to rearrange this number and then solve it by using the properties of whole numbers. So you can see if I add these two, it will be easy to add. And if I add these two numbers, it is going to be easy. So I'm just going to rearrange the number. So 1962, I'm going to add it with 1538 and this 453 I will add it to 647. So if you add it, 8 plus 2 is 10, carry over 1, 6, 10, carry over 1, 15, carry over 1. So you get 3500 here. and 7 plus 3 is 10, carry over 1, 10, carry over 1, 10 and 1, 11. So what do you get here? 46, 4,600. So if you add these two, you will get 4,600. Now let us try to solve this. What property we have used here? We have used here associative property. We have used here associative property of whole numbers, because associative property is for three numbers or more. So we have used associative property of addition because there is plus sign. Now here there are four numbers. So here also we are going to use associative property of multiplication. We are not going to add it in the same order because 125 into 8 is 1000 and 25 into 4 you know it is 100. So one more zero means give you 1000. So let us rearrange these numbers. So 125 into 8 and then 40 I am going to multiply with 25. So which property I have used here? Associative property of multiplication. So 125 into 8 is 1000 and 25 into 4 is 100. This one more zero. So how many zeros are here? 6 zeros. 1, 2, 3, 4, 5, 6. 6 zeros are there. Now, when you see these numbers, you can see 81,265 is common in these two numbers. So, we are going to take this number as common and we are going to apply distributive property here. So, I will take 81,265 common. So, when you take this common, what is left here? 169, and this minus sign written as it is. We have taken this common, so what is left here? 69. So 169 minus 69 is how much? That is equals to 100. So this is into 100. So what is the answer? You will multiply 81,265 multiplied by 100 means 2 more zeros you will put it here. Now you have to simplify this. So how are you going to do it? We can simplify this by breaking 103 as 100 plus 3 and then we can apply distributive property. So I'll write down here which property we have used here. We have used here distributive property. Distributive property. Similarly, the same property we will use it here. It is not given to you directly, but we have to expand it and write. So 738. I am going to split 103 as 100 plus 3. So now it will be easy for you to multiply. So as you know, well, first we will multiply 738 with 100. So 738 you will multiply with 100. This is plus here, so I am going to put plus 738 into 3. So here when you multiply this with 100, it will be followed by 730 followed by 2 more zeros because there are 2 zeros here. Now let us multiply this. So 8 into 3 is 24, carry over 2. 3 3 is 9, 9 plus 2 is 11, carry over 1, 7 is 21, 22. So now let us add these two numbers. So what are you going to get? You are going to get 4, 1, 8 to 10, carry over 1, 3 plus 3 is 6. So you get 76,014.